Hello and welcome to the Ready-Made Mathematics YouTube training videos. Teacher and teaching assistant mathematics training. This week is a whole week on mastery in place value. We're now up to day 3 and this is the second much shorter video to support children's visual understanding of place value of 2 and 3-digit numbers. In part 1, which I hope you've already seen, we've looked at using the abacus, a little bit of work on egg boxes and tens frames, and looking at how numicon and how those resources can support the understanding of ones, the ones value within every single number, taking that up to the tens value in each particular number. In this particular video, part 2, we're going to look at the sense of number, it's the sense of number 120 number grid. I'm going to refer to it today as the place value number grid, or the visual number grid, because it's basically 100 square that's been extended to 120, but also that gives you a picture of every single number within that 100 square. So if you use it with children, they're getting a visual understanding of each number every time they look at it. It's only a short video, but again, it does complement the other one, part 1, and even more importantly, it sets the scene for the work we'll be doing tomorrow with base 10 and when we move into 5 and a bit. So hope you enjoy the video and find it very, very useful.
Today we've been looking a lot at numbers less than 100 and how to see them in many, many different ways. Interestingly, until the final activity that we just looked at, where we looked at the number 27, the one resource we haven't used yet is base 10. Obviously, as I mentioned previously, that was deliberate because I wanted to make sure that children really had that ones understanding. Once they can really explore a number in ones through using the abacus, through using tens frames, through using numicon, and they've got more of an idea of what the ones value of a number is, then we're ready for base 10. What I'm showing you now is the sense of number 1 to 120 number grid, which again, I haven't mentioned this previously on the mental mathematics training, but I want to look at it now from a place value point of view. This is going to be one of the main focuses of tomorrow's training. Tomorrow we're going to be looking at the use of base 10 as part of the 5 and a bit structure, but also just generally how to use base 10 as a really powerful mathematical image. If I just home in on the grid there and just take a little bit of the central area of the grid, have a look at the numbers that you can see. How does this particular grid help us understand numbers in a way that a normal 100 square doesn't? In fact, I think I'm going to widen that out a little bit and let you look at the bottom of it. In fact, I'm going to focus down a little bit more. Let's home in a little bit on the bottom of the grid. So if we pause the video now, take a look at that section that you can see. Look at any of the numbers, just maybe choose 2 or 3 numbers and compare them. Look at numbers that are next to each other. Look at numbers that are above and below on the left and the right. And just look at them and discuss the value of the numbers and why this particular image is a little bit preferable to a standard 100 square. Let's have a look now at some of those numbers on the grid. If I just home in very quickly into the centre and we look at, let's say, 58, 68 and 78, what do you notice as that poster develops? Again, I'm going to show you, just go back a little bit. Let's look at all those numbers that end in 8 ones. 8, 18, 28, 38, 48. As you look at that now, you can visually see the number increasing. You can see it getting bigger and bigger. As we get towards the 58, the 68 and the 78, we can see 5 tens and 8 ones, 6 tens and 8 ones, 7 tens and 8 ones. So it gives the children a better understanding of the number because they can see it increasing by 10. It isn't just a numeral. Oh, the tens digit goes up by 1. Well, why does the tens digit go up by 1? Because we have 1 more 10. Then if we look in the middle at, let's say, 57, 58 and 59, and again if I scroll back, and let's look how that develops as we move along. If we start at 51 to 52 to 53 to 54, and as we home in on that, you can just see the reds are getting bigger and bigger and bigger. And as we end up at 57 and 58, you can see it increasing by 1 each time. As we get to that 58 and 59, we can start to see what's happening. They're getting towards another stack of 10. We're almost at a multiple of 10. We're at 59 and suddenly we get to 60. There's no ones anymore, it's just 6 tens. Now we know from all that work we've done today, there actually are 60 ones that are part of that 60. But at the moment it just looks like 6 tens. Again, something like that, what's happening on 100 square? Now this doesn't just stop at 100. As we look further down, you can see towards the bottom of the grid, we'll just focus there where you can see 95, 105 and 115. Again, why do number grids always stop at 100? It's like there's nowhere else to go after 100. And a lot of children even struggle to write the number 105. They'll often write it 1005. They write the number 100 because they've seen the number 100 before, and they write the number 5 because they've seen the number 5 before, but they've never actually seen a 3-digit number. So this really helps children see that much, much earlier. What does 105 look like? And why is it 1, 0 and 5? Well, look at it. What do you notice about the 105 that's very different to almost every number in the grid so far? What colour is missing? And again, what do you notice? Just say to the children, what do you notice about those numbers there? 101, 102, 103. What do you notice about them? What's the same about all of them? Well, they've all got blue and they've all got red. They've all got hundreds, they've all got ones. But more importantly, they've all got no tens. And that's really going to help. You can see there is 100, there are no tens, as we refer to 0 as a placeholder, and there are 7 ones, or in the one number that we looked at before, 105, 100, no tens, and 5 ones. As we look underneath, we then get to the number 115. Well, that one has got 100 and 110 and 5 ones. You can see how it's developed. You can see again as we get to 99. As you move along, we get to 99. There are 9 tens and 9 ones. What's going to happen now? Well, interestingly, the whole colour's changed. And if you follow down the tens, 10, 20, 2 tens, 33 tens, 44 tens, 55 tens, 66 tens, 77 tens, 88 tens, 99 tens, 100, 10 tens, but that's now been replaced with a 100 piece. So we can go from the 90 and counting tens, or from the 99 and counting ones. 99, 9 tens and 9 ones. We add another 1. That gives us 10 tens, and that's therefore exchanged for 100. Look underneath that, there's 100 and 110. So again, it's just a visual tool that I think is far more beneficial for children to see than a normal 100 square, which has numerals and nothing else on. They're almost learning in the abstract without looking at an image of what the numbers are. Now, I've deliberately shown you this particular image because this links very closely into a lot of the work that we're going to start off with on day 4. Day 4 is 5 and a bit for the majority of the session, but also I want to briefly look at the start of the session at how base 10 can be used, because as I said, that's the one image that we've not really focused on too much over today. I'm just going to take you back onto the ready-made math table now, just to have a quick look at some other base 10 apparatus that we are going to be looking at tomorrow. Now, this is a resource I will be looking at tomorrow. I'm just going to give you just a kind of a heads up, really. Let you have a quick look at it. These are base 10 tiles that have been created by TTS. As far as I'm aware, they're the only company, I think, that have ever created something like this. As you look at the numbers, which you've deliberately not put in order, we're going to discuss that tomorrow, you can see some beautifully visual images of base 10 apparatus and how that, how those numbers are built up. What you can actually see here is I'm just going to move around from a number on here to a number behind me on the 100 square. Let's just quickly look at the number 28. You can see the number 28 there, which is 2 tens and 8 ones. And if I turn around to here, we'll look at the number 28 on the poster. It's the same. It's 2 tens and 8 ones. Let's go down to 66. There's 66, 6 tens and 6 ones. As we move around, we'll see the number 66 down here. Again, 6 tens and 6 ones. Look up, there's 101, which is my 100. No tens and a 1. Move around to here, the same idea. Now, obviously, the colours are different on the number grid created by Sense of Number than on the resources that are created by TTS. But the idea is the same. It's basically like TTS have got the 100 grid and have turned it into large number tiles that can be used in class. I used this particular piece of apparatus, the TTS number tiles, last year in a school in Salford in year 1 with a whole group of year 1 children in the hall. I took 2 big groups of children and did different activities with each of the groups. I think I spent probably about 40 minutes with each group, just taking the year 1 children through a range of different ideas and activities using these particular resources. So I'll mention some of those tomorrow. It's a very, very nice resource, and it is different, I think, to most of the resources that have been produced to support place value. So tomorrow it is base 10 to begin with, where we're going to be looking at what we can get from these images and how we can use base 10 to develop place value understanding. And from then we're going to look at that 5 and a bit that I've been mentioning throughout the week.
And thank you very much for joining me for video 2. I hope you've just had a little brief input really into 2 to 3 digit numbers, and more importantly into base 10. We will tomorrow be really looking at base 10. That will be the main focus of tomorrow to begin with, and how that can be used, and visual pictures of base 10, and that will continue again into Friday. But thanks for looking at the second video. Again, if you haven't seen the first video, obviously the two do complement each other. The first video today is well worth looking at because it looks at 2-digit numbers using a complete different range of visual images, including the abacus, a little bit on egg boxes, and a little bit of work on Numicon as well. Thank you for listening and for watching, and I'll see you tomorrow for day 4.